All right, here we go. Welcome to lesson 4.5 geometry notes on dilations. This will be us wrapping up our chapter 4 notes. Last lesson here. Um, let's do it. It's straight up. It's one goal, basically identifying and performing dilations. Let's start with a little vocab, and then we'll talk about how we perform, how we identify dilation. So here we go. First off, so for your notebook, what we would have done in class. Dilation, defined it, box around it. It's a transformation that stretches or shrinks a figure to create a similar figure. That's straight up exactly what we need there. There's nothing to shortcut. Pause, add that. We'll talk here. Similar, so we're basically stretching or shrinking. We're getting bigger, smaller figure. This is our first transformation that we're looking at that actually changes the size of our pre-image. And similar is a concept that we'll use in future chapters. We'll have an entire chapter dedicated to similar figures. For right now, it's basically everything has been shrunk proportionally or stretched proportionally along the same rate or ratio. Okay. Again, without getting super hung up, basically what that's saying is we're not going to change the shape, just the size of it. Okay. Anyways, next thing we added, so kind of under your dilation notes, we added a note on scale factor. We just call it scale factor. One thing we said, we actually started with this. We said it was represented by the letter K. So you'll see that here in some of the examples that we use K as just to say, hey, your scale factor is this, K equals 2, K equals 5. And then what we said for what is it, we did say it's the ratio, but basically by which the original figure is stretched or shrunk. Okay, so we kind of cleaned it up a little bit. We said this, it's what is a scale factor? It's the ratio by which the side lengths of the original figure are stretched or shrunk. Okay. Okay, good. Next thing we did with scale factor, so I'm jumping here a little bit, but this is how we did it in class. Scale factor of a dilation, what is it? Represented by the letter K. Now, how would we find it? This will apply to this first example right here. To find scale factor, okay, so kind of like a subgroup on your scale factor notes, we said it's the distance from the center of the dilation to the image. And then like as a giant fraction, this is just going to be a single number. It's a distance, so a number on top, but it's from center to image over the distance from center to pre-image. Okay, that'll come up here in a second. And I know we're using some words there, center of dilation, that we haven't really talked about yet. For the most part, we're not going to. Our centers will always be the origin. Okay, but it's basically from where we're stretching or shrinking from a point. Okay, but we'll always be at the origin. So add this to your notes on how to find scale factor, distance from center to image over the distance from center to pre-image. We'll practice that here in our first example once we get there, okay? All right, back here now. The next note we added was the two types of dilation. So stretching or shrinking is kind of an informal way to think about it. There's the more formal terminologies are right here. So the first one we added was an enlargement. Okay, so set up a kind of in the dilation notes. These are all just kind of all part of dilations. An enlargement, you could probably figure out, it's literally in the word large, getting larger, enlarging something, is going to stretch it out. Okay, so all we said here was this. I know this is a little bit more technical. We said that K right here, so I'm trying to use that same K that we talked about right there. We said K is greater than 1, meaning what this says right here. Scale factor is greater than 1. If this means more to you, or you can interpret this as scale factor, which is K is greater than 1, just write this, otherwise write this out. And then all we said after that was the image is larger than pre-image is kind of what it should say, I guess. It seems like a typo there. Image is larger than pre-image. Or we could even say pre-image gets larger, going to the image, something along those lines. So we added enlargement. Scale factor is going to be bigger than 1. That's how things are going to stretch out. and the pre-image gets stretched, gets larger when you find the image. This is pretty good. If we said the image is larger than the pre-image, would be the only thing I would clean up right there. Okay, and then just going the other way, we did the exact same thing for a shrink, which we would technically say is what we would call a reduction. Okay, so we said this, the scale factor is less than 1. I don't like that. That's actually not a great way to say it. I'm going to say the scale factor is between 0 and 1. Okay, so it is less than 1, but we're going to say it's bigger than 0 because a negative scale factor really is, it's now you're building in another transformation. That's going to incorporate a reflection, which we're trying to stand alone here with just doing dilation. So I don't want to get too technical on it, but your scale factor should be between 0 and 1. Okay, and then all we said was, okay, we said that, and then we said, how about this? The image is smaller than the pre-image. I got to look at this. I don't know. I feel like in class we don't look at my notes all the time, and there's some stuff to clean up here. So the image is smaller than the pre-image is what I would say there. Okay, a lot of vocabulary, and I guess not a ton, but just some new vocabulary for us: dilation, scale factor, enlargement, reduction. How to find a scale factor we looked at. Let's do this. Let's get the notes part of the lesson done, and then we'll practice the examples. I think we can keep this one relatively short as far as the video goes, okay? Because the last thing you need for your notebook would be this. I'm going to slide it up because this is where it fits. Oh no, I was trying not to do the example. So to perform dilations, there's basically 2 ways we're going to do it, all right? As like a rule, so in class we called this method 1. So this can be your heading, performing dilations. Method 1 as like a rule. And then we wrote this, multiply. I'm looking at the board. I can see the same things on the board. Multiply all or each x and y coordinate by the scale factor, k. Okay. So that would be, it's going to say, if we wanted to look at what that looks like, in an example, it says use a dilation with the center at the origin and scale factor of 1/3. So that's the rule is saying multiply everything by 1/3. All right, that's method 1. Method 2, like pretty much everything else in this chapter, is matrices. Okay. And it's going to be the exact same process. How could we do a dilation and not multiply the x and y coordinates? So all we said was kind of the process and what it looked like. So this is what we said. We said use scalar multiplication. Okay. And that's from lesson 4.0 with matrices. Go back and watch. Otherwise, you'll see it here as it comes up. Use scalar multiplication to multiply the pre-image matrix by your k. Okay. And we did just a very simple demo of what that would look like. So this was all stuff we wrote out. You know how it gets set up on a quiz or a test or homework pre-image. There would be like a heading where I'd want you to put your pre-image matrix. There'd be a heading for your image matrix. So you'd have your pre-image matrix. You'd have your image matrix. Okay, they'd have the same notation that we always have: A prime, B prime, C prime, or A, B, C, and then A prime, B prime, C prime, whatever the coordinates are. I'm not even going to put coordinates in there, but you're going to see there's only 2 columns for pre-image and image. And then how does scalar multiplication work? It works like this, where I put my k, whatever it tells me the scale factor is, out here, and I would distribute it essentially to every x and y coordinate. Okay, so we multiply. So it's the exact same as using a rule. Multiply the x and y coordinates by the scale factor. That's what we're doing. These are all the x's. These are all the y's. We're multiplying by k. I put the results over here. That's just what it would look like as matrices. Okay, so that's the actual notes part of it. I don't have anything else but examples in practice here. Um, so let's do a couple. Everything else, examples 2, 3, and 4, you can kind of see it's graph, fill out the box, graph, fill out the box, graph. Make sure you have your matrices where they're supposed to be. The one that's kind of different than what we've seen is this first example. So make sure you check this one out here. It's asking me two things. It says find this. So this is the one, find the scale factor, where we're going to use this, find the scale factor. And then tell whether the dilation is a reduction or an enlargement. Okay. So let's do this. Let's talk through the process here. So I'm looking at a picture. They're actually kind of blurry here, I feel like, but I can see it. Hopefully you can see it's a pencil, like a sharpened pencil down here, and then a smaller pencil right here. All right. This stands for the center of the dilation. So that's where the dilation is like occurring from. Here's what I would do first. Okay, let's actually do this second part first. Tell whether it's a reduction or an enlargement. We're going to do that part first. How do I know that? Now, the part that you maybe are having a tough time seeing is look at these P's right here. This is P. This one is actually, I know it's really tough to tell, that's actually P prime right there. And that's important because that notation tells me that this is the pre-image, this smaller pencil, because it doesn't have the little prime notation. This larger pencil down here is the image because of the prime notation. So like I said, that's super important to know where the prime is. Over here, I can see the same thing. There's a little prime notation there. Okay, so just purely looking at the figures, this is my pre-image, this is my image. What happened to the pencil? Did it get bigger? Did it get smaller? Clearly it got bigger, so we're going to say that this is an enlargement. So I'm kind of doing this part first, and I'll show you why in a second. Maybe just because it's a little easier, like it got bigger, it's an enlargement. And then what's the scale factor? So this, for right now, I'm kind of checking out my notes until I learn how to do this. It says the distance from the center of the dilation to the image. What's the distance from the center of the dilation to the image? All right, again, that prime notation tells me that that's the image. That's a distance of 10. All right, that's the numerator of my fraction. And then my denominator is what's the distance from the center to the pre-image. So I go back, I look at the distance from the center to the pre-image, which is right here. That's a distance of 6 units. Okay, this is my scale factor, 10 over 6. I just want to reduce it. Okay, it's just like a slope or any other fraction you're working with. We'd always want to reduce that. So I would say for this one, they're both divisible by 2. I would make this 5. I'd make that 3. There's my scale factor, 5/3. We like fractions, I think, for the most part, better than decimals. So just reduce the fraction. The thing I should be checking, what was one of the notes we took here? We said for any enlargement, your K, your scale factor, should be greater than 1. So when I look at this, is this number greater than 1? It is. 5/3, it is. Okay, so that's the part that if you're having a tough time remembering which number do I put on top, it goes back to knowing that I think if you can remember that enlargements should be bigger than 1, and then reduction should be between 0 and 1. I think that'll help you kind of decide, should I flip this over or leave it as 5/3? Okay, let's do the second one. Same exact process. We're looking at the center down here this time. Okay, and I can tell by the notation, this was the original, the pre-image, and it's being shrunk to a smaller version. These are both, it's an eraser. So it looks like a school supply example here. Eraser got a little bit smaller. I can tell just, there's no like secret to that. Like, did it get bigger or smaller? It got smaller. So I'm going to call that a reduction because that's what it is. And then we'll do our K, or find our scale factor. And again, I've got two numbers. This kind of boils down to is, should it be 11/22 or 22/11? Now, if I follow straight off the notes, it says from the center to the image is my top number. And then it says center to the pre-image is my bottom number. But now again, if that's tough to remember, because it is, I feel like I even want to flip-flop that sometimes in my head. If I reduce this, I get 11/22. That's 1/2. They're both divisible by 11. Now I'm trying to decide, is that the correct scale factor? Now, if I'm 100% confident that this is a reduction, and I am because it got smaller, my scale factor, whatever I say, better be a number that's between 0 and 1. And this is 1/2 is between 0 and 1. You know, obviously the answer could be 2 over 1, but that would be an enlargement and things wouldn't be lining up. So that's something you can do to kind of check and just make sure that the reduction in your scale factor line up, or an enlargement in your scale factor line up. Okay. So hopefully that makes sense. I got a couple for you to practice on the homework there. The rest is all performing the dilations yourself. Okay. So I think we're going to do them all, but we'll go quick just because, like I said, I feel like at this point in the lesson, or this part of the chapter, I think most people are feeling pretty confident with the graphing part, the notation part of it. They're ones that we're not going to spend a ton of time. If you're new or you haven't seen any of the other previous lessons, and you're starting with this one, you probably want to go back and make sure that you get some of the notes from the previous ones as far as where some of this notation is coming from. Okay, so I'm going to start. If I read here, I've got vertices of the quadrilateral, blah, 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 listed out in front of me. Let's plot them. I've got -3, 0. I've got 0, 1, 2, 3, 4, 5, 6. I've got 3, 6, 1, 2, 3, 4, 5, 6, and 3, 3, 1, 2, 3, 1, 2, 3 right here. Boom, 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 boom. Okay. Obviously, I've done this one before, so it's one that I feel like I'm kind of know where the points are and it goes quick. Counting A, B, C, D. All right, so that's just me plotting the pre-image. In the end, these are all worked that way. It says graph ABC, ABCD, which we did, and its image. That's what we're going to come up with right now. Okay. The rest of this is kind of like a stock phrase. It says find the image of ABCD after a dilation with its center at the origin. Ours will always say centered at the origin. Okay. And then this is the part that I'm looking for, is the 1/3. All right, so that what this means, right, if I check my rules, it says multiply the x and y coordinates by the scale factor. That's ultimately what has to happen. I need to multiply this, and this all get multiplied by 1/3. So you might have to use a calculator, depending on what the scale factor is. I'm going to get all the notation part of this set up just like we would on any other graph and notation that we've done for this unit. A prime, B prime, C prime, D prime. And I'm going to multiply everything by 1/3. So what is -3 times 1/3? It's -1. What is 0 times 1/3? It's 0. What is 0 times 1/3? It's 0. What is 6 times 1/3? 2. And then most of these we've done already. What's 3 times 1/3? It's 1. 6 times 1/3 I just did. That's that 2. And then 3, again, we just did up here. So 3 times 1/3, 3 times 1/3, those are both 1. That takes time. I'm going quick there. I can multiply that stuff in my head. It goes obviously a little bit quicker if you can do that. But again, for you, if it means plugging those numbers into your calculator, absolutely do that. That's how we come up with those numbers. And then short of just plotting it here, we're done here. So where's A prime? -1, 0. 0, 2, 1, 2, and 1, 1. Look at that. It's like a cute shrunken down little version of the bigger quadrilateral. I'll label it A prime, B prime, C prime, D prime, and that's it. So what happened there? Basically, the blue one got shrunken down. It always gets so my center is right here. We said of the origin. Everything's kind of pulling back towards the origin. Yeah, so that's what happened there. You don't have to tell me an enlargement or reduction. It was a reduction, but I would ask you questions like on the previous example like that. We knew the scale factor. Okay. Okay, keep her moving. Example 3. We could also do this exact same thing with like a composition, right? This is what we learned about in the previous lesson, where we're doing just multiple transformations on the same figure. No big deal. Let's do it. So I'm going to plot my image. Okay, -1, 2, 3, 0 is right here. -1, 2, 1 is right there. And then -1, -1 is right here. So I'm starting with a very small triangle, K, L, M. And remember, in order here, I have to start at the top. Okay, so I'm getting my notation set up. This is going to be K prime, L prime, M prime. And what am I doing first? I'm going to add 4 to all of my x's here. So that gives me a 1, that gives me a 2, that gives me a 3. Look at that. And then on the y's, we are going to add 2. So that gives me a 2, that gives me a 3, and that gives me a 1. So now this is 1. I'm still going to plot it. I like plotting that second one, but you don't necessarily have to. All right, so where are we at? 1, 2, 1, 2, 1, 2, 3, and 1, 2, 3, 1. Okay. Again, you don't necessarily have to put that one on there because it just says to graph the triangle and its image. This is kind of an in-between. But like I said, it's not a huge deal. It doesn't take much effort to put that one on there. Okay. Last transformation is, I'm kind of shortening up my arrows here. K double prime, L double prime, and M double prime. Where does that come from now? That's me doing this dilation centered at the origin with a scale factor of 2. So that's me now taking 2 and multiplying it by all 6 of these numbers. That's where all my new x and y coordinates are going to come from. So let's do it. 1 times 2, 2 times 2, 2 times 2, 3 times 2, 3 times 2, 1 times 2. Great. Awesome. There it is. Let's plot it. Let's graph it. We can tell because the K is bigger than 1, so this should be an enlargement. This triangle is going to get bigger. So where are we at? 1, 2, 1, 2, 3, 4. Of course, I ended up right on top of my notation there. 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And then 2, 2. 1, 2, 1, 2. Uh-oh, what happened there? It doesn't look right. 1, 2. That's not right. Oh, I didn't. What happened here? Was anybody going to tell me? I don't even know what I did there. Oh man. Sorry about that. I was going too fast and I forgot that we were doubling everything. All right. So this 3, I think I said times 2, and I just wrote down a 2. So this should have been 6 right there. There we go. 1, 2, 3, 4, 5, 6. 1, 2. That feels a little bit better. So K double prime, L double prime, M double prime. Glad I caught it before posting and sharing the video. So hopefully go back and adjust if you need to. We multiplied by 2. I think I said it, but I didn't write the correct number in there. So you can see the progression. We translated right 4 up 2, and then took this one and enlarged it to come up with that double prime triangle there. Again, hopefully stuff that you're comfortable with already. Last one, though. Let's do a matrix one. I mean, it makes sense. We've done everything else as matrix. This is our last example. And then, yeah, that's the lesson. So I'm going to kind of get set up here with my pre-image matrix. Right? This is stuff that if you're wondering about where this is coming from, you got to go back and watch previous examples or previous lessons, I should say, because we go over how to turn a matrix or how to turn ordered pairs into a matrix. Okay, I can graph that one right away. Negative 1, 2, 3, 4, 5, 0. 0, 1, 2, 3, 4, 5 is up here. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is over here. I know I'm going quick, but I'm pretty sure if you're watching this video at home or in study hall, you can handle it. The pace. You can pause, obviously, as needed. All right. How does this work? Okay. We said in the notes we were going to use scalar multiplication, meaning I'm going to stick the scale factor, which if I read ahead is right here, scale factor of 3/5. Kind of goes on the outside of my pre-image matrix. And then I need an image matrix set up right here, like as placeholder. So I need an A prime, a B prime, and a C prime. And then let's see, did we hit everything else? We need to do the multiplication. So just like before, we're going to multiply every one of these numbers by 3/5. The results go here. We plot it. We say thumbs up. Life's good. All right, here we go. What's 3/5 times -5? Let's see if I can not screw this up here this time. We're going to get negative 3. 3/5 times 0 is 0. And then 3/5 times 5 is positive 3. 3/5 times 0 is 0. 3/5 times 5 is 3. 3/5 times negative 5 is negative 3. Okay, I'm obviously picking convenient numbers here that multiply nicely by 3/5. It doesn't always have to work that way. I feel like on the homework, there's somewhere you get halves, 3.5 or 2.5. That's okay. You could still graph 1, 2, 3.5, up 1, 2, 3.5. That's okay. That's going to happen sometimes. So you just kind of estimate where those points would be. Obviously, we didn't have that here. Let's plot this one 1, 2, 3, 0, 0, 1, 2, 3, and then 1, 2, 3, 1, 2, 3 is down here. So this one's kind of unique in that it kind of pulled. They always either pull from or expand away from the origin. The red triangle got shrunken down because that's a number between 0 and 1. It shrunk us down. It reduced us closer to the origin, and we ended up with a triangle that was completely inside the other one. So just a unique look. Nothing special. I mean, we didn't do anything different. Just kind of the way that one looked. So. Let's see. I think we got them all there. Graph, pre-image, and image. Everything's labeled correctly. That's it. So that's it. That's your lesson on dilations. Hopefully everything in there made sense. That's chapter 4 too. So that's all I got. I'm gonna wrap it up there. We'll check off our. Oh, I screwed that up last time too. I wanted to check off that we were done. And I will see you in future lessons.